Yeah, so the second one that we're going to do, a better evaluation metric, is going to be from the receiver operating characteristic curve. Characteristic curve, ROC. So a metric that we're going to get here is the area under this curve, under the receiver operating characteristic. So area under ROC, or auROC. What this graph does, it plots the true positive rate. It plots the true positive rate on the y-axis, and it plots the false positive rate on the x-axis. So the true positive rate, it has a name. It's called sensitivity. If you want to call it by its name, sensitivity. And then the false positive rate is 1 minus specificity. If you want to call it by the scientific names, I can say scientific names. So that's what it does. So this ROC is plotted like this, right? So what happens is this. Let's quickly just plot an example. Or so this is the true positive rate, and this is the false positive rate. So it can be plotted like something like this. Something like that. And usually Python will plot like a line in the 45 degree angle like that. So let's explain what this means. So when you plot an ROC curve, you want the model that is very close to this top left corner, which is 0 0, coordinate 0 0, which is coordinates, let's see, no, it is like 0 1, right? 0 1, yeah, 0 1. Yeah, it's going to be on the x is 0, and then on the y it's 0. That's what you want, right? And the model in this top, when it is at this top left corner, it's going to have a false positive rate equal to 0%, and a true positive rate equal to 100%. It's equal to 100% there in this top left corner. And that's exactly the model that is absolutely optimal. Many of the models that you're going to write are probably not going to really be like like a square like this. Nah, probably not. But the closer you get to this top left corner, the better the model is. But looking at it, it's difficult to really tell, like, okay, which one is the better one? So you can calculate the area under ROC, or the auROC, and this is the area under the ROC curve. So the area under the auROC, because we want the curve to be close to this top part here. What that basically means is, if the AUC increases, you are building a better model. Imagine a graph like this. It doesn't have a better. It's not closer. It's not closer to the top left compared to this original one that we had. And by that observation, we can conclude that the original is a better model. And using AUC, you can also tell what is the area under this curve. The second one is definitely less than the area under the first curve. So AUC is a very good one because it shows you how close it is to the top left corner. So the higher the AUC, the better the solution is going to be. Let's look at our model, our logistic regression. When you look at our logistic regression, this is what we're doing here. After we did our precision recall curve, here we're now starting to calculate the ROC curve. We calculated our thresholds and everything, false positive rate, true positive rate. And then we calculated our area under the curve based on the false positive rates and the true positive rates that we had. And here we just plotted them. We plotted the FPR, TPR. We just plotted them nicely. And as you can see, this is the model. looking at it like this, it might be difficult to really say how close is it. It's difficult for me to really see how close it is, but you can look at the area under the curve like we did here. We said that we put a title, receiver operating characteristic, area under the curve, and then we calculated it, area under the curve as we calculated here. That is the area under the curve. So area under the curve, that is from the logistic regression, is 0.97. 0.97, which is good because 1 is the ultimate best. It is the ultimate best, but it is good. But how good? Our question is, how good is it? It might be good, but there might be a better model. And that's what we'll be looking at in the next coming videos. Random forest, XGBoost, and like GBM. Those will be faster videos because we have explained the principles, and like I keep saying, the structure is going to be the same. The structure of the code is going to be the same when we do random forest. You see the structure here for, I'm scrolling up. I hope you can see the structure here. The data has already been read in, has been cleaned if needed to be cleaned, and here we started our logistic regression. The structure is going to be the same. Create your hyperparameters in the model, do cross validation, do your log loss for the cross validation, calculate your precision, Rico curve, average precision, calculate your ROC curve and area under ROC, and then we are going to compare those metrics and choose a model that works, that gives us the best metrics. So let's see each other in the next video where we move on to the random forest model.